Hey guys, I have your notes here for, I don't know what we really call this, Chapter 9 Miscellaneous or Identifying Conic Sections or whatever. So I don't care what it's called, but we had to put this at the very end after dealing with a bunch of conic sections. Now that you've had experience working with the equation for a parabola, the equation for an ellipse, and the equation for a hyperbola, I expect that if one of your teachers was to give you an equation of a conic section, this is going to be hard to read because, there we go. If we were to give you an equation of a conic section and say, already in standard form, and say, okay, you can have your formula sheet right beside you, identify what type of graph this would be. All you would have to do was directly match the equation that your teacher gave you with the equation on this sheet. However, what if we gave you an equation in polynomial form? What if your equation looked like this? It didn't look like one of these on the paper. Could you tell me what it is at a glance? That's our goal for today. So, I am going to be using the sheet that, there's a copy of it in your packet. It's also in Google Classroom. The one in Google Classroom is color-coded. Now, don't worry, there's a lot of stuff here. It's all stuff that you have done, you know how to do. When I go through the steps, and I'm going to go through them very quickly, I'm not going to say anything that should confuse you. You know the words I'm going to say. I'm going to say FOIL. I'm going to say distribute. I'm going to say multiply both sides by. I'm going to say rearrange terms, okay? So I'm going to flip over here to parabolas. I'm going to start with parabolas. That's what we started with at the beginning of the chapter. So, it is cutting off, my screen is cutting off part of this picture. I think you can kind of see it. So up there at the top, I've got both standard form of a parabola. This is a standard form of a parabola that opens up or down, right? The x is being squared. This is standard form of a parabola that's opening left or right because the y term is being squared. In each equation, only one variable is going to end up squared, okay? So I've done all the math. Just kind of follow me. Ready? What if you FOIL this? You would get this, yes? Now, next step. So I FOILed it both sides. Next step, distribute the 8. This is what your equation would look like. Get everything on one side. This is what your equation would look like, right? Don't you see that only one variable is being squared here? It's just the x. So if I see this in polynomial form, I'd be like, oh look, only one variable is being squared, and it's the x. This is a parabola. This equation is a parabola that opens up or down. This one, over here, only the y term is being squared. I don't have an x term that's being squared. Only one variable is being squared, it's the y. So I would say, oh look, only one variable is being squared, it's a parabola. Not only that, it's the y that's being squared, so it opens left or right. So you should be able to quickly identify a parabola, up, down, left, right, by only one variable is squared. That's going to be easy. Now, let's flip over to ellipses. Ellipses are the next thing that we did. Here's an equation of an ellipse in standard form, right? There's a plus sign in the middle. And let's see, this is the bigger of the two. So my oval, my ellipse, is going to be elongated vertically. Whatever, doesn't matter. It's an ellipse, right? All right, the first thing I'm going to do is I'm going to multiply everything by my lowest common denominator to clear my fractions. Why am I doing this? I want to show you that this transfers to polynomial form. so that when we get it to polynomial form, you can say, oh, that's what an ellipse looks like in polynomial form. I knew what it looked like in standard form. I didn't know what it looked like in polynomial form, so here we go. Multiply everything by 36. Ready? I'm going to put a 36 in that fraction, a 36 in that fraction, and a 36 over here. And now look, these reduce. These reduce. Here's what I get. 36 over 4 reduces to 9. Right? Okay, next thing I want to do, FOIL each of these out. I'm going to FOIL this one out. Check. I'm going to FOIL this one out. Check. Don't you wish math went this fast all the time? Okay, so I FOILed them out. The next thing I want to do, distribute my 9 in. Distribute my 4 in. The next thing I'm going to do is rearrange my terms. I'm going to put both squared terms in the front of the polynomial. Why? So that you can see I've got an x term that's being squared. I've got a y term that's being squared. Their coefficients are positive. Why are they positive? And they're different. Why are they different? Why are they positive? Why are they different? Go back up to the beginning. Oh, dang. Back up at the beginning. They're both positive because this fraction is positive, which means my x squared term is going to be positive. This fraction is positive, which means my y squared term is going to be positive. And their coefficients ended up being different because their denominators were different in the first place. Okay, summary, ellipse. Both terms are squared. Your coefficients, the 9 and the 4, are both positive and different. Circles. We didn't talk much about circles, but hey, you're going to get this. This is an equation of a circle. How do I know? Well, it looks like an ellipse equation, doesn't it? Which way is it stretchy? Is it stretchy the x way or is it stretchy the y way? Neither. A and B are the same, thus a circle. This is an equation of a circle. The only difference from an ellipse is these two have the same denominators. Okay, same process. Ready? Let's multiply to clear out the fractions. So I'm going to multiply everything by 4. Multiply everything by 4. Hey, let's FOIL this out. Let's FOIL this out. Here we go. I FOILed it. Let's rearrange some terms so that my squared terms are in the front. There you go. Check it out. Both terms are squared. They're both positive. And their coefficients are the same. Their coefficients are the same. It's a circle. Last one, hyperbola. That is really, really cut off, and I'm not sure why. I'll just have to try to hold it in place. Okay, so here's an equation of a hyperbola. Remember how there was a minus sign? And we're not looking for the bigger of the two numbers. We're looking for which one is positive. So because the number under the x squared is positive, the hyperbola would open from side to side. Whatever. It's a hyperbola, right? There's a minus sign. Let's go with this. I'm going to show you what it looks like in polynomial form. Multiply everything by 36. 36, 36, 36. These reduce. So now there's a 9 in front of there, and there's a 4 in front of here, and there's a 36 on the other side. Next thing I'm going to do, I'm going to FOIL out this one, and I'm going to FOIL out this one. This is acting so funny. All right, so I FOILed them out. See, FOILed it. Foiled it. Now, I'm going to distribute my 9 in. I'm going to distribute my -4 in. Rearrange my terms. I'm going to put both squared terms in the front. So the 9x squared is in the front, the -4y squared is in the front. See how both both variables have a squared term, and one of them is negative. Which one? It's the y term it's the y squared term that's negative. Did we know it was going to be that way? We did. I did. I think you did. I knew it was going to be the y squared term that was negative because that's the one that had the negative in front of it at the very beginning. So, hyperbola. One of the two coefficients is negative. It doesn't matter whether they're equal or different. What matters is that one of the two coefficients on the squared term is negative. Okay, switch over to the notes. Pause it. Copy down what I just said. Circle, when A and B are both equal and both positive. Ellipse, A and B are blah, blah, blah. Copy it down. Now, let's identify these. You ready? First one, first of all, there's two squared terms. That eliminates parabola right away. So, A and B are different and positive. Different and positive, it's an ellipse. Moving right along. Next one, squared terms. Oh. There's only one squared term. What is it? It's a parabola. Next one. There's only one squared term. Look, see? Only one. It's parabola. Next one. Ooh, there are two squared terms. Check out their coefficients. They're positive and they're equal. They're positive, so that rules out hyperbola. We've already ruled out parabola. It's either an ellipse or a circle. Remember how a circle had the same exact denominators? This is a circle. Because once we do all that math to clear the denominators and FOIL everything out, because they had the same denominator, their coefficients end up being exactly the same. Next one. Two squared terms. Oh, look, that one's negative. One of them is negative. One is negative, thus hyperbola. Hyperbola. Next one. Oh, look, two squared terms and both coefficients are positive. Nope. You need to get them on one side. You need to group them together. They don't actually have to be in the very front but they do have to be on the same side together. So this would be 5y squared minus 4x squared, blah, blah, blah. The rest doesn't matter at all. Here's what matters. Hyperbola.